Hi everyone, today we are going to solve the LeetCode question, longest repeating character replacement. So you are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operation. So let's see the example. So you are given like a, b, and the k is 2. Output should be 4 because replace the two A's with 2B or vice versa. So let's say if I change this A to B and also this I change this A to B, in that case we get 4B. That's why our output should be 4. Or if I change this B to A, A, and this B also change it to A. In that case, we get like a 4A, so that's why output should be 4. So to check the longest substrings, we use like a left pointer and a right pointer. But how can we know this range is valid or not? So that is the most important point of this question. So let me explain how to solve this question. Okay, so let me explain with this example. So you are given A, B, A, B, B, A, and the k equal 2. So first of all, I initialize left pointer and the right pointer with index 0. So this freq variable is the most frequent character number between left pointer and the right pointer. So I'll explain how to use later. So first of all, initialized with 0. And this is a return value, result variable. And this is a hash. So basically, I iterate through all characters one by one. And every time I put a current character into hash. And what we are trying to do is that we get a range. We get a range between left pointer, right pointer every time. Why is that? Because, okay, let's say right pointer is now here. So what is the max range between left pointer and right pointer? It's obvious, from index 0 to index 3. So if I change this B to A, so we get a 4A. So in that case, we successfully get so max range, which is 4. So how about this right pointer is now index 4. So in that case, what is the max range between left pointer and right pointer? It's obvious, from index 0 to index 4. So in that case, if I change these 2B to A, we get successfully like a 5A. So in that case, we can get a max range between left pointer and right pointer. Yeah, it makes sense. So actually, there is a formula to calculate the range between left pointer and right pointer. So formula is right minus left plus 1. So this is a formula to get a range between left pointer and right pointer. So for example, now left pointer and right pointer is 0. So 0 minus 0 plus 1 is 1. So now we only find A. So yeah, this formula should work. So how about this? So right pointer is now here. So index 1. So 1 minus 0 plus 1 equal 2. So now range between left pointer and the right pointer is now 2. So yeah, this formula works. So we use this formula to calculate the range between left pointer and the right pointer. Okay, so let's start iterating. First of all, we find A. So add A to hash 1. So most frequent character is now 1, A. So result variable also 1. It's obvious. And then move right to next. So again, we find A. So add A to hash. And then most frequent is A, so now 2. And the result variable also 2. And then move next. We find B. So add B to hash. But still A is the most frequent character, so I don't update frequent variable. And for result variable, so we can change the character twice at most. So if I change this b to a, we get a 3a. So that's why result variable should be 3. And then move next. Now we find a, so add a to hash, and the most frequent character also 3. And again, if I change this b to a, we get 4a. So result variable should be 4. And then move next. We find the b, so add b to hash. And the most frequent character still a, so we stay 3. And the result variable, if we change these two to a, we successfully get 5a. So result should be 5. And then move next. So actually this is an interesting point. So now we find b, so add b to hash. And then now the range between left pointer and the right pointer is now here. And then now we have 3a and 3b, but we can only change the character twice at most. So in that case, we cannot max range between left pointer and right pointer, because if I change a, it's like 1a and 5b. Or if I change b to a, it's like 5a and 1b. But range between left pointer and right pointer is now 1, 2, 3, 4, 5, 6. So 6. 6 is like a longest substring. So in that case, we need to shorten the range between left pointer and right pointer. And there is a formula when we need to shorten the range between left pointer and right pointer. So we know that right minus left plus 1 is a formula for range between left pointer and right pointer. And then minus frequent is greater than k. In that case, we need to shorten the range between left pointer, right pointer, because so usually we change the character that is not most frequent character. So if this condition valid, we cannot get max length between left pointer and right pointer. So in the case, r is 0, 1, 2, 3, 4, 5. So 5 minus 0 plus 1 minus most frequent is 3. 3 greater than 2. So in the case 6, 3. So this is a 3. 3 is greater than 2. In that case, we need to shorten. So how can we do that? It's simple. Move left pointer to next. And then remove most left character, in this case a. So we need to reduce the number, like add minus 1 to a. So now a is 2. So again, so 5 minus 1 plus 1 minus 3 is greater than 2. In the case 2. So this condition doesn't meet. So in that case, compare little bit messy, but now length is like here. So current max length substring is now 5, and the current max length is now 1, 2, 3, 4, 5. Actually, right minus left plus 1. So okay, so in that case, so now we have a 2a and 3b, so we can change character twice. So if I change this a to b, so we successfully get 5b. So that is the longest substring between the left pointer and the right pointer. So yeah, now looks good. So but 5. So current length is 5. And yeah, now we have a 5 for the longest substring. So it's same. So I don't update the result variable, but I keep going. Move next. And now we find A. So add A. Oops. Again, we have 3A and 3B. So actually, it's the same situation. So we have a chance to change the character like twice at most. So in that case, so now yeah, a little bit messy. So let me change the color. So now left pointer is index 1, and right pointer is at the last index. So we need to shorten the range between left pointer and the right pointer. So update left pointer to next, and then remove the most left character A. So now A is 2, and then the range between left pointer and the right pointer is now here. So now so current max length should be right minus left plus 1. So 0, 1, 2, 3, 4, 5, 6, 6 minus 2 plus 1 and 5. So and it's same. So I don't update the result variable. And then go to next, but there is no character here. So that's why 5 is a return value, longest substring. Yeah, that is a basic idea. It's a long explanation. Yeah, but I hope you understand the concept to solve this question. And time complexity is order of n, because I iterate through all characters like one by one. So with that being said, let's jump into the code. Okay, so let's write the code. First of all, initialize left pointer result variable with 0, and the most frequent character number initialize with 0, and the character count with empty hash. So start looping for right in range length of string. So first of all, add current character to hash. So hash s and the right equal 1 plus get try to find the current character. If we don't find, default value is 0, and get the most frequent character number. So freq equal max freq versus, and the most frequent character should be the character we just added here. So compare two numbers, and then do you remember the formula to shorten the range between left pointer and right pointer? So we check here. So while right minus left plus 1 minus frequent is greater than k. So in that case, we cannot the max length substring between left pointer and right pointer. In that case, first of all, remove the most left character from the hash. So s left minus equal 1, and then update left pointer to next. So after that, just compare current length versus new length. So right minus left plus 1. Yeah, actually that's it. And then return result variable. So let me submit it. Yeah, looks good. This solution works. So I told you the time complexity is order of n, but I forgot to say space complexity. Space complexity is also order of n because I use hash here. So basically I put all characters into hash, so that's why a linear order of n. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of longest repeating character replacement. So step 1, initialize the result variable, left pointer, right pointer, the most frequent character number variable, and hash. And step 2, start looping, add +1 to hash for current character, and get the most frequent character number between left pointer and the right pointer. Step 3, shorten the range between left pointer and the right pointer until we don't meet right minus left plus 1 minus frequent is greater than k. Step 4. Compare current longest with the range between left pointer and right pointer. So that's it. I hope this video helps you understand this question well. If you like it, please subscribe the channel and hit the like button or leave a comment. I'll see you in the next question.